Hi, I wrote this simple simulator so that you could practice water balancing. Now this simulator consists of 4 coils: coil A, coil B, coil C, coil D, and a pump, and it's got an overall bypass. It's very similar to the water balancing rig we have in the TAFE. Each one of these coils has got a control valve, and 3 of the coils have got bypasses. Each of the coil has got a STAD valve, a balancing valve on them, and the one with bypasses have got bypass balancing valves. You can see all the flows. This is really quite good. It's a bit too busy really in many ways, but anyway, you can see the flows, the turns that you have the valves set to. You can open and close the control valves. Let me just show you. I'll open this control valve, and as you open the control valve, it happily recalculates all the flows. You can change the pump speed. So I'll turn down the pump speed, and you'll see as I turn the pump speed down, the flows change. And over here you can see the total flow, design flow, and total flow. Now, each one of these coils has got what's called a design flow. The first coil, coil A, design flow of 7, that's just here. Second B is design flow of 4.5. Third one C, design flow of 2. And the third one, design flow of 3. The nice thing about this is you can see the flows all at once, whereas in the real world you can only see one flow at a time. So I'm going to set this up then in initial state for water balancing. So the first thing I'll do is I'll turn the pump up full. 43, where have we got? 50. Okay, so the pump's at 50 Hertz. And I'm going to put all the flow valves into 100%, which means the stuff is flowing fully through the coils and not going down the bypasses. Nearly there. That's 100. Turn C to 100. And D is already 100. Now, to ensure that I don't get a problem with anything going through the bypasses, I'll turn all the bypasses, I'll close all the bypass valves. So that's that one closed. Close this one. That's B closing. The other thing which is easier with this is, of course, real flows tend to be fluctuating up and down all over the place, whereas my flows on my simulator just stay exactly where they're supposed to. Okay, so I've closed all the bypasses. D doesn't have a bypass. And now I'm going to open the STAD valves to full open. Now, full open with a STAD valve is 4. You can physically wind it further than that, but they're only calibrated to 4. So that's 4. Turn that one to 4. Open that one to 4. And open that one to 4. Now what's really important is that you make sure that the main bypass is closed. If you don't, you'll get bad results. So the VSD is at 50 Hertz. The line valves, the line STAD valves are all open fully to 4, and the bypasses are all set to 0, and all the control valves are set to 100%. Okay, so looking around the system at the DPs, we have DP at A of 671 and a flow of 7.74 litres per second. The design flow is 7, the actual 7.74, so it's actually getting 110%. Now when you're doing this, you have to manually calculate all this stuff, but this is doing it all for me. On valve B, design flow of 4.5, actual flow 5.05, so that's 112%. On valve C, design flow of 2, actual 2.14, 107%. On valve D, design flow of 3, actually 3.3, and 110%. Okay, now firstly, I need to create what I'm going to call my index, which I'm going to balance the rest of them to. Typically, we want the index to be the heat exchanger that's the furthest away from the pump. So that's valve D. But in this case, we need to also take into account what's the lowest ratio. And the lowest proportion is 107 here at C. And valve D is at 110, which is more than 107. So in order to make valve D the index, which we want to do because it's furthest away, what we do is we close the valve until it's about 2% less than the lowest. So we'll close that until this 108 becomes 105. 105 is about 2 less than 107. So I'll close that to 108, still 108, 107, 106, 105. Right. Now one thing you'll notice is as you close one valve, you slightly increase the flow in all the rest of the system. That's because the water has to go somewhere. So closing one valve makes the rest of them go up, but only slightly because it's only a very small valve. So that one's now set to 105. Now, I want to set all of these to 105. That's my index proportion. That's my design proportion. So the design flow for this one is 2, but the actual, what I want to get, my proportion is going to be more. We expect the proportion to be always more or less than 100. There's lots of reasons behind that. Mainly it's the design of the system. Our job isn't to bitch and moan that we don't have enough water or we got too much water. Our job is to proportion them all. We can sort out the not enough water, too much water later, but for now we're just going to proportion them all. So I'm going to proportion them all to my index, which is 105%. So I'm moving along to C, and I'll turn that down until it's at 105%. There you go, 105%. And then I go to B and close that valve until I'm at 105%. Oh, just a bit more. 106. That's where I'll have to go to. Okay, and now I'll go to A and close it down till we're about 105%. Now, A is a bigger valve, so as I close it down, I'm increasing the flow for all the others. So, when I've got this at 105, I go back to D and make sure that it hasn't changed too much. The flow has increased slightly, but it's still 105%, so that's okay. Right, that's the balance done pretty well. That's it balanced now. They're all proportioned to each other. Now what I'm going to do is I'm going to set the bypasses up. So I'll start at A. A has got a bypass. A's flow is 7.4 litres per second. Its DP is 955. I might look at the DP, 955. So the DP across here is 955. What I'm going to do is I'm going to change the control valve to bypass. Now, as I do that, because the STAD valve on the bypass is completely shut, then as I change the control valve to bypass, the flow will go to 0. So that's that valve shut now. The flow through A has disappeared pretty well. There's still a little bit of flow because there's a little bit of leakage past this valve. Now, I need to put that back as it was. I think it was 955. I can't remember now, so I'm going to put that back. Should have made a note of it. Open it back, yeah, 955. Right, I need to get back to 955. But with the flow not going through the heat exchanger, but going through the bypass. So I open up this balance valve while watching the DP up there until it goes back to 955. And when it does, then I know that the flow through the bypass will be the same as the flow originally was through the heat exchanger. Nearly there. Nearly. There you go, 955. Right, that'll do. Oh, just went a bit too much. Just close that. There, got it. So that's that one done. And I do the same for the next one. This one, 1698. 1698, I need to remember that number. Turn the valve around. And open the balance valve until we get 1698. And I'm not looking for the DP on this, I'm looking for the DP on the line balance. So I'm adjusting the bypass while looking at the DP on the other stat. 1698. Nearly there. Nearly there. Oh, a little bit over. Might close that a little bit. That'll do. As close as I'm going to get. Okay, so that's that one done. And finally the valve C, 850 I want to get to. So I'll turn the valve down, flow will just about disappear. And I'll open this one up until the main flow goes back to a DP of 850. Oh, just over, went too far. The 850, good. There it goes. Now they're balanced. Everything is balanced. They're all balanced with a percentage of 105%. It's all balanced. It's all good. What I might do now is I might just turn the VSD down a bit and see if we can get exactly 100%. It's not part of the water balancing. You've actually completed the water balance at this point. Bang! That's near enough. Or maybe just... Okay, so at 48 Hertz, they're effectively at 100% of their design flow. So that's it. Make a note of all the valve positions and you have completed your balancing.